Hello, in this video we're going to show that we can take a 1 degree of freedom non-central chi-square distribution and write it as a Poisson weighted mixture of central chi-square distributions. Now, background, I have a video called Relationship Between Double Factorial and the Gamma Function, and we illustrate this formula here for when n is odd. Now, if we substitute 2n plus 1 for n and then rearrange, we can write it like this, right? So this 1/2 comes down, this comes down, that goes, we can write it like this. And we're going to make use of this property on the second page. But this can be found in this video. Now, also background is a Taylor series for e. So e to the x can be written like this. It's sort of a well-known result. But we can put different things in for x, and it still converges. So if we put in the square root of y times lambda, then we can write it like this: the 1, the square root, well, and if you take the square of the square root, you just get it back, and so forth. Or we could stick in minus square root of y times lambda, and then we get this. Now, if we add these two, notice that the odd terms all cancel, and we're left with 2 of each of those. So if we add them, but then divide by 2, we basically get the even terms back, which can be written like this. Now, one more piece of background information before we start. I have a video called Statistical Distribution, Central and Non-Central Chi-Square 1 degree of freedom distributions. And in there we go in and derive the PDFs for the central and non-central chi-square distribution with 1 degree of freedom. So the PDF of a 1 degree of freedom non-central chi-square distribution can be written like this. Okay. Well, if we take this piece here and substitute it in for this piece of the formula, we get this. So this all carries down, and then we substitute this in. And then I think next what we do is we pull this into the summation sign, and we kind of separate it. So, and I'm going to go back just to illustrate here. So this y to the n can be put with this y to the 1/2. But if we combine the exponents, then we get 2n minus 1 over 2. But to kind of put it in the chi-square formula, we have to add 1 and subtract 1. And so that's when you see the next page that will happen. So e to the minus 1/2 y, and it can be split to times e to the minus 1/2 lambda over 2, or lambda, and the rest stays the same. So here, here's the lambda to the n, and then the lambda, or the y to the n, was combined with the minus 1/2 into this. The e's were separated, and then all the junk that was over here we just put over here. Now the next step is this piece here, the gamma of 1/2 times 2n factorial. Now on page 1 we have an identity for that, and it was this. So for this piece we plugged in this. Okay, now the 2n to the 2n can be thought of as 2n times 2 raised to the n times 2 raised to the n, because then when you combine them you get the n plus n, which is 2n. But if we separate them, so we keep it 2 to the n times 2 to the n, one of those 2 to the n's can be combined with this one to make it lambda over 2 to the n, and then the 2 to the n and 1/2 can be combined. Okay, so then we're going to put this piece under here, and then we're going to move the extra 2's over here. then we'll keep this piece separate and this square root of n factorial separate. So that's what we do here. So those are now put over that. And the reason that we do this is because this is a central chi-square distribution with 2n plus 1 degrees of freedom. And this is a Poisson distribution. So it can be thought of as a mixture distribution of central chi-squares with Poisson weights. And that's what we set out to show. Well, I hope you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.